video, I want to focus on converting parametric equations to Cartesian equations with a specific focus of trigonometric parametric equations. So parametric equations that involve trigonometry. So to illustrate how to convert a parametric equation to a Cartesian equation, I want to start with a classic example. So let's suppose that we have a parametric equation as follows. Let's say we have 2 cos theta minus 3, and y is a half sine theta. Now, what we want to do is to form a Cartesian equation. Remember, a Cartesian equation is a relationship between x and y only, i.e. theta must be eliminated. We're not allowed to have theta in the answer. Now, with parametric equations that are converted to Cartesian where it's not trigonometry, we simply make theta the subject. Sometimes t is the parameter that's used. Notice if we do that here, we end up with a horrific expression which will involve arc cos and arc sine, and it certainly won't give us the nice Cartesian equation that we're hoping to achieve. So what we do with trigonometric parametric equations that we're hoping to turn into Cartesian equations is we isolate the trigonometric functions, i.e. the cos theta, the sine theta, maybe in another example it will be sec, tan. In other words, we have to get rid of the minus 3 and the 2. So let's do that first. Get rid of any coefficients or any other terms. So from here, we can see that cos theta, I'll add the 3 and then divide by 2, is x plus the 3 and then divide by 2. For y, we need to get rid of the halves, we need to multiply, so that's 2y is sine theta. We have now isolated the trigonometric functions, which in this case is cos and sine. So what we need to ask ourselves at this point is which trigonometric identity relates cos and sine? Well, it's the very first one you learn in the A-level course. Cos squared plus sine squared is equal to 1. So what we should do is write that down and fill in corresponding expressions for cos and sine, and then theta will completely vanish altogether from the equation. Cos theta is x plus 3 over 2. So cos squared theta must be the square of the numerator and the denominator. Don't bother expanding the brackets, just put x plus 3 in a bracket and square it. So you do x plus 3 squared over 2 squared, which is 4. Sine squared is the whole thing squared. It is not 2y squared, it's 2y all squared. So it becomes 4y squared is 1. And that is a Cartesian equation. A Cartesian equation is just an equation that relates x and y. In the exam question, they might specify a specific form. Maybe they want y to be the subject, y squared to be the subject, y cubed perhaps. But if they don't specify any relationship between x and y that does not have theta or t in it, is a Cartesian equation. So in this case here, that is the Cartesian equation for these parametric equations. Okay then, so here we have another parametric equation. We have x is cos t plus 2, y is 4 sec t. Using a similar method to the example I just showed you, can you try and find a Cartesian equation? So I recommend pausing the video there and have a go at this problem. Right, okay, let's go through it then. So like we said, the first thing to do is to isolate the trigonometric functions, which in this case is just cos t, there's no coefficient there, and sec. So let's do that first. So x minus 2 is cos t, y over 4, I need to get rid of that 4, is sec t. So we've got cos and sec in this problem, and how can we relate cos and sec? Well, by the definition of sec is 1 over cos. So I'll just use the formula arising from the actual definition of sec is 1 over cos. And then replace what our equivalent expression for sec and cos is, and then t will go, and we'll be able to get y and x related. So sec t is y over 4, so let's do that. Let's put y over 4 for sec. 1 over cos t would be 1 over x minus 2. And if the exam question requires you to make y the subject, which in a problem like this it probably would, since it's not so difficult, you'll then multiply up the 4, and the final answer would be y is 4 divided by x minus 2, which means that effectively that these parametric equations is a reciprocal graph. Okay, so this example is a little trickier. There's a little bit more to do than the previous examples. So I'd like you to give it a go. Pause the video and see if you can get a Cartesian equation for these parametric equations, and perhaps you'll realise as you go through why it's a little bit more to do than the previous examples. Right, let's go through it then. Now there are no coefficients or other terms, so we have the trigonometric functions that we wish to relate, cos t and sin 2t. And the next thing to do is to identify a trigonometric identity that relates these two functions. And hopefully we realise that sin 2t and cos t, there's only one possible formula that we could use, which of course is the double angle formula for sin 2t. That's the formula we wish to use. So let's try and fill it in the best we can. Sin 2t is y, which means that's y. The 2 I can just replace. The sin t, I don't have sin t. I've got sin 2t and cos t, and that's where potentially the problem lies here. So for the sin t, I'm actually just going to leave that as sin t. However, cos t I can do. Cos t is just x. Put some multiply signs here so we don't get confused. Now, this is the issue. I've replaced sin t, I've replaced cos t, but I don't have an equation for sin t. So how do we get an expression for sin t? So if you're left with any trigonometric function that you're yet to replace, the answer lies in the original equations. So where do I get a clue? How can the original equations help me? If I need sin t, well, which one is going to help me? You have to ask yourself, what is sin t related to? Well, sin t is related to cos t. Why? They are related by the identity sin squared plus cos squared is 1. So although I have a formula for cos t is related to sin t. I can equivalently get a formula for sin t if I wanted to, which is what I need to do here. So if I've got cos and I need sine, the formula you must use is cos squared t, plus sine squared t is 1. So cos t is x, which means cos squared t is x squared. Sine squared t is what I'm looking for, so I'll leave it as it is, equals 1. Therefore, sine squared t is 1 minus x squared, but we don't want sine squared t, we want sine t. So then I need to square root both sides. And then we take this and we insert it in replacement for sine t, which means the final answer is y is 2x, I've squeezed the x next to that 2, and then 1 minus x squared, all square rooted. Okay, final example for this video. Again, a reasonably complicated one compared to the previous examples, where x is tan squared t plus 5, y is 5 sine t, and the Cartesian equation you're looking to get has to be made of this form. Y squared needs to be the subject, and you're just allowed any function of x on the right hand side. So get those down and see which trigonometric identities you're going to use for this example. Okay, let's give it a go. So first of all, we need to get rid of that 5. We also need to get rid of that 5. So we can see that x minus 5 is tan squared. Let's slide that 5 down. So y divided by 5 is sine t. So the issue perhaps you might find is that sine and tan don't have a direct identity that we're aware of that involves just sine and tan. Like sine and cos, sec and tan, they have a formula that relates one to the other. We have formulae that has sine and tan in them, but they usually involve another function. So you've got a few options what you could do here. Okay, I'll show you 2 different ways of doing this. Okay, so to start with, we know tan can be written as sine over cos. That's perhaps the most obvious way of doing this. So I need to find a formula that relates tan and sine. So I could say, well, tan squared is sine squared over cos squared. So I could write that as sine squared over cos squared. And sine squared I could write, because sine squared is y squared over 25, square both sides. Which is good, because I need to get y squared in the answer. So sine squared over cos squared is y squared divided by 25. Cos squared, notice we don't have. Right, we've got sine, we don't have. Now sine squared over cos squared, remember, was tan squared. So actually this whole thing, sine squared over cos squared, which is tan squared, is this, x minus 5. So that is x minus 5. The only thing now left to do is to get cos squared, and then we've got rid of t, which is what we wanted to do. Again, like the previous example, how can I get rid of cos squared? Well, if I need cos, or cos squared in this case, I'll go to sine, because sine and cos are related. So if I square this to get sine squared, then cos squared is just 1 minus sine squared. So if we do a working up here, we know that sine is y over 5, so sine squared is y squared over 25, and I know sine squared is 1 minus cos squared. So that must be 1 minus cos squared. And therefore switch these around. Cos squared is 1 minus y squared divided by 25. So if I slot that in there, we get x minus 5 is y squared divided by 25, divided by my newly found expression for cos squared, which is over here, which is 1 minus y squared over 25. Now, the only thing left to do is to make y squared the subject. If you remember, we were required to make y squared the subject. So what I suggest we do is let's multiply the top and the bottom of this fraction by 25. It will get rid of these denominators. So we have x minus 5. If we times the numerator by 25, that will go. So we've just got y squared. If we times this by 25, we get 25. And again, multiplying this term by 25 will just eliminate that denominator. Now we're going to have to bring this term up. So we end up with x minus 5 multiplied by 25 minus y squared is equal to y squared. Now we multiply out. But I'm not going to actually multiply the x minus 5 bracket out. I'm just going to say x minus 5 times 25. So if you take all of this bracket multiplied by 25, you get 25 by x minus 5 minus, again, another bracket of x minus 5 multiplied by y squared equals to this y squared. And then I can move the y squared terms across. So, Let's now multiply this out. So let's do 25x minus 125 equals, and collect together the y squared terms. We've got one y squared on the right hand side, plus we're going to have another new bracket of x minus 5 on the right hand side. So it's plus another x minus 5 lots of y squared. And lo and behold, we're about to finish the problem. Y squared is this, 25x minus 125 divided by, just sort the 1 and the minus 5 out, which is minus 4, divided by x minus 4. However, I did promise a second way of doing this, and some of you might prefer this method. We used tan squared is sine squared over cos squared to solve this problem of converting this into a Cartesian equation. So let's think how else we could approach it. So remember at the beginning of the last problem we would have done x minus 5 is tan squared, and y divided by 5 is sine t. Let's think about a different way of doing this. A useful tool for parametric equations is to consider the reciprocal functions. So sine and tan do not share an identity that has sine and tan in it only. However, if you consider the reciprocal functions, they do. Consider the reciprocal of sine. The reciprocal of sine, 1 over sine, is cosec. So if sine t is y over 5, then cosec t is 5 over y. Cosec and tan also don't have an identity that has cosec and tan in it only. However, what's the reciprocal of tan? It's cot. So if I reciprocate this, so if I do 1 over x minus 5, which must be 1 over tan squared, you get cot squared. Now suddenly, this looks like good news. Why? Because cosec and cot have an identity. Cosec squared is 1 plus cot squared. The advantage of this method is you only need to use one identity. So cosec squared is 1 plus cot squared. Let's fill it in. Cosec squared, it's squared, notice. That's only single, so we're going to have to square this. So we end up with 25 over y squared is 1 plus, now cot squared is what I'm after. I've got cot squared already. You need to look out. Sometimes you have the single function, sometimes you have the squared function. So I've got cot squared already, so I don't need to square this. It's just 1 over x minus 5. All we need to do now is to isolate y squared. Now, in this particular approach, y squared, there's only one y squared term. Remember the previous way we did it, we had quite a lot of algebra to get y squared to be the subject. What I suggest we do first of all, however, is to sort the right-hand side out. If you've got two fractions that you can combine, you should combine them. So we end up with 25 over y squared. If I write this as x minus 5 over x minus 5, you end up with x minus 4 over... And now we just need to cross multiply and finish this off. So if I multiply this by this, we get 25x minus 125, bring the y squared up, and then divide by x minus 4, and there we go.